Okay, hello everyone. So I would like to add just one small explanation on your exercise. Okay, so I will solve this problem 1.43. This is on the review on statics. Okay, so you have we call this a pin jointed truss. So you need to determine the reactions at supports A and C. Okay. And then that's the first question. The second question is determine the axial force in each of the following members. So you need to have member AB, which is F1, member BC, F2, and member CD, F3. So that's the internal force, okay, the internal force. So let me mention the member AB. This is one here. Here, AB, it can be like that, and the axial force. And member BC, maybe here. And then member CD, maybe here, okay. Or maybe here, okay. Now, to start with the questions, okay. So we need to observe what will we have in the information. So this is, we call the truss, okay, the all the members, okay, it's connected through some pin, like this pins here, that pin, okay. And then we have a supports in A and C. If we closely take a look the A and C, A is just a normal pin supports, and C we have a roller support. What's the difference? The difference is we can imagine that on C, we are going to have free movement on x-axis, right? So the only reaction that C has will be just the only that Cy, okay, force. For A, we have in x-axis, also in y-axis, okay? Okay, that's just for the observations. Okay, now what we are going to do is first drawing the free body diagram. So what we are going to draw is basically all the truss, okay, just to simplify the picture. So let's say this is the free body diagram. I would like to draw, this is AB, this is AC, okay, that's the one side. Okay, this is A, B, C, D. Okay, and then we take this AX, and this is AY. Oh, this is the external force that applied. That 1 kilonewton. And then what else? Oh, C. This is CY. Okay. And then all the distance we have this will be 0.6. And this will be let me and then this part. Eh, wait, this 1.2. Okay. Okay. Okay, now we take the sigma of moment. Let me start with A. Okay. We start with A, it's equal 0. So we are going to look at this part here and this part. This will be our distance. So this will be the applied force. So 1 kilonewton multiplied with this length and length. Okay. So 1.2 plus 0.6. So let's say the clockwise is positive. So 1 multiplied with 1.8. And then minus cy. This will be counter, right? So cy. And then this will be 0.6. So cy. Okay. And okay. Let's calculate. This is 3, right? Okay, do I make mistake here? Okay, and then we take the x, and we find that only has the ax and it's equal to 0. Okay. And then the y-axis, this is ay plus cy equal 1 kilonewton. So ay is 1. Wait, I think I make something wrong here. Ay is, oh, it's negative, so 1 minus 3, so minus 2 kilonewton. So I make wrong arrow, so it should be goes there. Should be going here. Okay. So it's, or we take ay 2 kilonewton. Okay. Ups direction. So that's ay. So ax is 0, ay is 2, and cy is 3. Okay. That's the supports at A and B. Okay, so this is A. So B, okay. So member AC. So AC, we need to break down the truss. Okay. Okay, after we get the free body diagram, to answer the second question, we need to first identify the internal force F1, F2, F3 in the Faber diagram. And then another important thing is we describe the angle in between, right there, and also here, right, for F3 and F1. Okay. All right, now we could take the equilibrium now for AB. We take the equilibrium for the moment. Let's see, supposed to be 0. Okay, so we have F1 and then with the distance of AC. Okay, distance of AC. So the distance of AC will be the 0.4 and 0.6, right? That is with the help on the angle, and we know the angle since this is 0.6 for this one and this one is 0.6 also, so we know the angle will be pi over 4, right? Pi over 4, because it has the same amount of length. So we could take the tangent theta equal 1, so theta will be pi over 4, right? So this theta is pi over 4. We could change this to pi over 4, or right, pi over 4. Okay, that's the angle there. Now we could take the F1 and then we could let me write with the blue colors. So we could take this, become F1 sine pi over 4. I hope it's clear. And this one here is F1 cosine pi over 4. Okay, so to begin with, let's say we are going to take the clockwise as a positive. So we start by taking F1, it's positive now, to the C is 0.6, so F1 sine pi over 4, and then multiply with 0.6, and then F1 cosine, also positive, multiply with 0.4, right? Now this is F1 cosine pi over 4. We need to go here, so it is supposed to be here, right? So this will be the moment. Okay, that's the F1. And then what else do we have? We have the this 1 kilonewton, right? 1 kilonewton. 1 kilonewton. It goes through the 1.2 meter. So it goes to from here and goes there. Okay. So that will be so that is plus 1 kilonewton multiply with 1.2 meter, right? Okay, what else do we have? Okay, I think we could calculate the F1, right? Oh, I forgot the oh, no need to take the sorry. We are going to evaluate internal force, okay, only the AC. So AC, I forgot the this AY here. So AY, this is going to be this distance, and this is going to be counterclockwise, so it will be negative. Okay, sorry. So 2 kilonewton, or let me just 2, and then 0.6, and this equal to 0. Okay. So this is only apply, I forgot to mention here, to AC. Okay. So this is only the internal force at AC, right? Okay, so F1, this will be sine pi over 4 is square root of 2 over 2, right? Well, since they are both the same, let me just take outside here, and then this will be 1, right? And then this will be 2 multiplied by 0 0.6 is 1.2. So F1 is, let's compute. Wait, let me compute first. Where's my calculator? Okay, here is 1.2 multiplied by 2 divide. It's 1.697 kilometer. Okay. Okay, that's I think good. Now we could go for the next one. The next one is the equilibrium at B. Okay, let's say, so we take the sigma moment at B. Okay. Okay, now to begin, let me start with this. Okay, that's the tangent theta is 0.7. So theta is tangent inverse of that. Okay, let's calculate first. So this will be 30.25. Let's check. Okay, I think it's correct. This is degree. Okay, degree. Okay, what else do we need to have is now it's BC. So this is BC. So this first one is AC, this one is BC. All right. Okay. Okay. I think for this one is for the CD. Sorry. I think this is CD first. Okay. I think let's try CD first to take the F3. Okay, I hope it's okay. So this is CD. Okay, let's solve this. So this is F3 cosine, and this is F3 sine. Okay. Oh wait, wrong. Oh yeah, correct. Sorry. Okay. So on the CD we have. Okay, now look at the BC. We are going to take the F3, and let's say we are going to have clockwise positive. So F3 to B is going to be counterclockwise, so F3 cosine theta. Okay, F3 cosine theta, and the distance is 0.6, 0.4, which is 1 meter. That's the first one. And then what else? 0.6 and the AY. So we took only this part here. So actually, for this number B, you could erase all this stuff here. I think that's still okay, right? Yeah, we could erase this because all this 1 kilonewton is already distributed to this F1, F2, F3. So I think this will be better observations. So F3 cosine theta 1 meter, and then the other one, this AY, this is also a negative. This is 2 kilonewton, and 0.6 meter. Okay. This is equal 0. So I think we could take this F3, and then cosine theta is, let me check my answer. Is 0.86, and this is 1.2. So 1.2 divided with the answer is, so this will be means the opposite directions. So I think this is supposed to be here. This is F3, not here. Right, okay. Okay. So F3 is going there. And then to find the F2, we could take the equilibrium at y equals 0. So we take I think that's better. So sigma f y equals 0. So f1 sine pi over 4 plus f2 plus 3 kilonewton minus 2 kilonewton minus f3 sine theta. Okay, so this will be equal to 0. Okay, so f2 is negative 1 kilonewton, and then f1 sine pi over 4 this is 1.19. Let me write it's at 1.2 kilonewton, and then 1.389 sine Okay, I hope you can uh, be careful on the signs. Okay, just to take notes on that. So 1 plus 1.2 plus 0.6 69. Oh, it's supposed to be a plus here. So plus, so negative, yeah, correct. So 1 minus, so plus, okay, 1 point F2 is negative. Okay, maybe just notes whenever you are having negative signs, just keep that still negative, okay, for all the calculations, and then at the end you can make some conclusions, okay, because if not, then maybe you will have some difficulty on maybe confusing on the result or in the process, okay. So to avoid the confusions, just using as it is, okay. I think this is my answer for F1, F2, F3. So this is the direction. So the F2 is going to be down there. So it's not going up here. It's going to be that way, F2. Okay. So that's just the additional informations on exercise. Okay.